Good morning everyone. In the last video we have discussed about the problems that the demerits with the Bohr's atomic model, and we have also discussed that what is the quantum number. We have said that the quantum numbers are the address diary for any of the electron within an atom. So here we are going to discuss about the quantum number in detail. So when we talk about the quantum number, then how many type of the quantum numbers are? There are four different type of the quantum number, that is the principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number, as you knew well. In the last video we have discussed about it. So here we are going to discuss in detail about these of the different quantum number, and we are starting with the principal quantum number. When we talk about the principal quantum number, it is represented by small n. This represents the cell, that in which of the cell the electron is surviving, whether that is surviving the first cell, second cell, third cell, fourth cell, fifth cell, whatever the cell number is. And the principal quantum number is always a positive integer. If the cells are k, l, m, n, then the principal quantum number for these of the cells will be 1, 2, 3, 4, 5. So simply you can say that the cell number is the principal quantum number, and this number is always a positive integer. So here this is the principal quantum number, which is always a positive integer and suggests that in which of the cell the electron is surviving. The value is always a positive integer. Now we are going to see the next quantum number, that is the azimuthal quantum number. Azimuthal quantum number is suggested by letter L. जैसे हमने देखा था प्रिंसिपल क्वांटम नंबर की वैल्यू हमेशा एक पॉजिटिव इंटीजर होती थी. व्हाट विल बी द वैल्यू फॉर द azimuthal quantum number? The value of azimuthal quantum number with respect to n, the value of L will be 0 to n minus 1. For example, if the value of n is 1, 2, 3, 4, 5, etc., then what will be the possible value of L? The possible value of L will be 0 to 1 minus 1, that is only 0. 0 to 2 minus 1, that is 0, 1. 0 to 3 minus 1, that is 0, 1, 2. In the case of 4, 0, 1, 2, 3, 0, 1, 2, 3 and 4 in the case of 5. Here you can say that the azimuthal quantum number 0 is suggesting the S subcell, 1 is suggesting the P subcell, 2 is suggesting the D subcell, and 3 is suggesting the F subcell. Then these are the different azimuthal quantum number and different subcells. Generally only these are the 4 subcells are used during the electronic configuration. The azimuthal quantum number is not just telling that what is the subcell, it is also capable to tell about the shape of the cell. Actually, the azimuthal quantum number suggests that what is the number of nodes in the cell. I think you knew well about the nodes. हम हिंदी में कहते हैं गांठ. The area where the probability of finding is 0, that is called the node. So these are the subcells, these are the azimuthal quantum number are suggesting that how many points are there, how many planes are there where the probability of finding the electron is 0 in these of the subcells. So we are going to discuss about the shape of the subcells according to azimuthal quantum number here. So when we talk about the shape of the natural species, if there is any natural species in absence of any of the external factor, external force, then what will be the shape of that species? The shape of that species will be spherical. Why spherical? Why not any other shape? Why not tetragon, octagon, tetrahedral, octahedral like something? क्योंकि जब हम बात करते हैं किसी भी सिस्टम के स्टेबल शेप की, तो हम कहते हैं दैट शेप विल बी द मोस्ट स्टेबल विच हैव द लीस्ट सरफेस टेंशन, and that species must have the least surface tension which have the least surface area. और जब आपने मैथ में पढ़ा था मेंसुरेशन नाम से टॉपिक, सॉलिड ज्योमेट्री नाम से टॉपिक, तो वहां पे आपको आपके टीचर ने पढ़ाया था द spheres have the least surface area for the same value of the वॉल्यूम. अगर वॉल्यूम सेम हो तो स्फीयर्स का सरफेस एरिया सबसे कम होता है. द स्फीयर्स हैव द लीस्ट सरफेस एरिया विथ रिस्पेक्ट टू अदर स्पीसीज, एंड दिस इज द रीजन व्हाई द नेचुरल सब्सटेंसेस सर्वाइव इन द स्फेरिकल शेप. So we are considering that there is a natural spherical shape for these of the system. So when you will talk about the S subset having azimuthal quantum number 0, then the system will remain spherical because there is no any node on the system. There is no any external force is working, there is no any node is working, and this is the reason why the S subcell have the spherical shape. But when you will talk about the P subcell, you can see the azimuthal quantum number for the P subcell is 1, and having azimuthal quantum number 1, the system have one node. If we are considering that this is the condition and here is a node in the center, you can consider a balloon. ऐसा बैलून जिसे आप बांधने से वो फूटे नहीं, तो उसे बीच में से बांध दीजिए. क्या होगा? एक लोब इधर निकल आएगा, दूसरा लोब दूसरी तरफ पे, तो शेप क्या हो जाएगा? The shape will be somewhat like this one. The shape is called the dumbbell shape. This one was spherical, that the S subcell was spherical, having no any node, and this one is dumbbell, and this is the nodal surface. This is the plane, nodal surface, where the probability of finding the electron is nil. I have already told you that the nodes are the zone where the probability is 0. Probability of finding is 0. So here the probability of finding of electron is 0 in these other subcells. Now we are going to talk about the D subcell. We have talked about the P subcell. We are going to talk about the D subcell. And when you will see the D subcell, you can find that the azimuthal quantum number for the D subcell is 2. Having azimuthal quantum number 2, there will be two nodes. One node is here. Where will be the next node? It will be somewhere here. And when you will tie in this way, when you will make a node in this way, you will find 1, 2, 3, 4 lobes, just like this one. And this shape is called dumbbell shape. Then this structure is a double dumbbell shape. This one was dumbbell and that is the double dumbbell shape. Now when we talk about the F subcell, the F subcell have spherical, P subcell have dumbbell, D subcell have double dumbbell. Then what will be the shape of the F subcell? When you will talk about the F subcell, you will talk about the azimuthal quantum number, that is the 3. And having azimuthal quantum number 3, there will be 3 nodes on the 3 different axes. So the first node was here, second node is here, and where will be the third node? Third node will be somewhere here in this way. And when it will be in this way, you will find that the same number of nodes will be above the plane and same number of nodes will be below the plane. And whatever the shape is developed, that is called complex shape. No structure is given in your book. Even you can assume the structure, but actually the structure is not given. So in exam, no one is going to ask about the structure of the F subcell. So this is the subcell's structure, subcell's shape according to azimuthal quantum number. So here azimuthal quantum number is capable to explain that which of the subcell, in which of the subcell the electron is surviving, and it is also capable to explain that what is the shape of the subcells. Here I want to clarify that what is the subcell. Subcell is a zone where the probability of finding the electron is maximum. More than 99% probability is there. We can't say that the probability is 100% because Schrodinger wave equation is suggesting that the probability of finding the electron is till the infinite. यानी कहीं पे भी इलेक्ट्रॉन पाया जा सकता है, but the maximum probability of finding the electron is only within the orbital. So this is the shape of the different subcells. Now we are going to see the next quantum number, that is the magnetic quantum number. So here magnetic quantum number suggests the orbitals and their orientations. So what will be the value of the magnetic quantum number? First of all, the magnetic quantum number is represented by the small m, and with respect to azimuthal quantum number, the value of m will be minus L to plus L including 0. That means if the value of L is 0, 1, 2, 3, actually it is for the S, P, D and F subcell. So for the S, P and D, F subcell, the azimuthal quantum number is 0, 1, 2, 3. Then what will be the magnetic quantum number? As we have already told you that the magnetic quantum number will be minus L to plus L including 0. For the S subcell, it is 0. That means from minus 0 to plus 0. That is only 0. So there's only one magnetic quantum number is there for the S subcell. That is suggesting there's one orientation, only one orientation is there for the S subcell. Now for the P subcell. For the P subcell, the azimuthal quantum number L equal to 1. So the magnetic quantum number will be minus 1, 0 and plus 1. Total 3 different quantum numbers. When you talk about the D, it will be minus 2, minus 1, 0, plus 1 and plus 2. Total 5 magnetic quantum number. And in the case of F subcell, it will be minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. These are the magnetic quantum number. I have already told you that how many orbitals are there, that will be suggested. Here it is saying that the S subcell have only one orbital, P have 3 orbital, D have 5 orbital and F have total of the 7 orbital. This one is also going to explain about the orientation. It is suggesting that the S subcell have only one possible orientation, whereas P subcell have 3 orientation, D subcell have 5 orientation and F subcell have total of 7 orientation. Then what are these of the orientation? Orientation means where the orbitals are surviving with respect to axis, whether that is surviving horizontal, vertical or whatever the position is there. That position with respect to that of the axis is called the orientation. So here we are going to discuss about the orientation of the different orbitals of the subcell by using the magnetic quantum number. And we are going to start with the S subcell. So see here, in the case of S subcell, the shape is spherical. एक बॉल को कंसीडर कर लीजिए जिसपे थोड़ा डिजाइन वगैरह ना बनाओ, सिंपल सा बॉल. अगर आप उसे रखते हैं तो क्या आपको लगता है कि ये सीधा है, टेढ़ा है, वर्टिकल है, हॉरिजॉन्टल है, ऐसा कुछ फील करते हैं? शायद नहीं. और अगर नहीं करते तो क्यों नहीं करते? इसलिए नहीं करते बिकॉज व्हेन यू विल सी the mass distribution with respect to the center, you will find the identical mass distribution is there. जितना leftward है उतना ही rightward है, जितना upward है उतना ही downward है, हर एक डायरेक्शन में identical है. And if it is so, you cannot provide the different orientation to the system. जहाँ पर भी रखेंगे mass distribution वैसा ही रहेगा, तो एक ही orientation possible है. And this is the reason why the S subcell have a single orientation. There is no any other orientation for the S subcell. But when you will see for the P subcell, then there are 3 orientation as the magnetic quantum number is suggesting. Then here it will be 3 orientation. First on the axis X, that will be called Px. The second one on the axis Y, that is called Py, and the third one on axis Z, that is called Pz. So these are the 3 different orientation for the P subcell on axis X, Y and Z. Then Y only on the X, Y and Z, Y that is not surviving in between these of the orbits. So when we talk about these of the systems, we talk the distribution of the electron in such a way. The orbitals must contain the electron, so we are talking about the electron distribution. The electron distribution will be in such a way that the repulsion of each other must be reduced or cancelled by each other. So in this condition, when these of the systems are perpendicular to each other, they each are cancelling the repulsion force for each other, and as a result whatever the force is working on these of the electron, that is zero. And because of the reason the system gets stabilized, and because of the reason these of the orbitals are surviving on the axis x, y and z. I think it's clear to all of you. And now we are going to see about the Dsubcell. When you will talk about the Dsubcell, there are 5 different orientations for the Dsubcell, and we are seeing that what are the 5 different orientations for the Dsubcell. So in the Dsubcell, the 5 different orientations are there, and where is the orientation? When you will talk about the Dsubcell is a double dumbbell shaped system. There are 4 lobes. So the first orientation is somewhere here. That means on the axis x and y, and this is the region, this is called dx square minus y square, because it is at the axis x and y. The next one is on the axis z. अब यहाँ पे आपको मालूम है डबल डंबल है, 4 लोब्स हैं, यहाँ पे तो 2 ही लोब आएंगे, एक ही डंबल आएगा, दूसरा डंबल कहाँ गया? Actually this is the position, the x axis is somewhere here towards you, and when it is towards you, the next one will be at 45 degree, and that is not stationary, that is rotating with the respect of this one, and as it is rotating, the rotating orbital will be represented in this way. So this is the rotating orbital at 45 degree, and this is the stationary. This is x, y and z, and this orbital is called dz square. These are the 2 orbitals combinedly are called axial, or according to Mulken they are also called EG. Axial because they are surviving on the axis, so they are called the axial. Only these 2 are surviving on the axis. When you will see the next one, यहाँ पे देखिए मैंने 2 के 3 की जगह पे 2 ही एक्सिस ड्रा किया है, और ऐसा इसलिए ड्रा किया है क्योंकि जब हम इक्वेटोरियल पोजीशन को ड्रा करते हैं, इन बिटवीन एक्सिस ड्रा करते हैं, तो कभी कभार कंफ्यूजन हो जाता है कि वो इन बिटवीन एक्सिस है कि ऑन द एक्सिस है, ऑन द जेड एक्सिस है। तो इसलिए मैंने एक एक्सिस को यहाँ पे शो ही नहीं किया है, क्योंकि थर्ड एक्सिस एक्चुअल में तो यहाँ होती है, लेकिन रिप्रेजेंट करने के लिए 2D में हम यहाँ पे उसे ड्रा करते हैं, तो हम उसे ड्रा नहीं किए हैं। इफ दिस इज द एक्सिस x and y and the orbitals are surviving in this such condition, that means in between axis x and y, then it will be called dxy. If they are surviving in between axis y and z, then they will be called dyz. And in the case of next, when they are surviving in between axis x and z, then it is called dxz. So these are the 3 are called the equatorial. That means they are on the same plane. That means all the lobes whatever surviving, they are on the same plane, and this is the region they are called the equatorial. And these of the equatorial are also known as T2G. The first one is called the EG, and this one is called the T2G. Now about the F-subcell. When you will talk about the F-subcell, there are 7 orientation from -3 to +3. That is the -3, -2, -1, 0, +1, +2 and +3. But when it is the time to draw the orientation of the F-subcell, you already knew that the F-subcell is a very much complex shape in 3D, and it is very difficult to represent these of the 3D orbitals on the 2D surface like this blackboard. And the 7 different orientation drawing on this blackboard, that is almost impossible. And this is the reason we never show the orientation of the F-subcell. Just know that there are total 7 orientation in the case of the F-subcell. Finally, the last quantum number, that is called the spin quantum number. When we talk about the spin quantum number, in a plane there are only 2 rotations possible. The first rotation is called clockwise rotation and second rotation is called the anti-clockwise rotation. So there's only two value of the spin quantum number, that is the plus half and minus half. For the clockwise rotation you can say it is the plus half, and anti-clockwise rotation it is the minus half. In any of the orbital there are only two electrons possible. That means any of the orbital can contain maximum of two electrons, and both the electron must have the opposite spin, because both the electron have the different spin quantum number, and this is represented by all of these of the quantum number. And this is all for today's video. In the next video we will discuss some of the rules like Ohm's law, Pauli's exclusion principle, and I will also explain how to find the quantum number. Thank you and have a nice day.